Hello, we're back here on the channel here in Davos, World Economic Forum 2025. I'm here with my friend, my collaborator, Professor Dr. Ramesh Raskar. Ramesh, it is so good to be with you here today. The first question I have for you is, how do you get it all done? You are one of the most prolific human beings and scientists that I know of, and I know many, many prolific people, but you're running two different labs at MIT, the decentralized AI lab, the camera lab that has been breakthrough after breakthrough. We'll talk about some of those in a minute. You author papers, you're advising multiple companies in a very deep, scientific, technology impactful way. And you have family and you have friends and a big life as well. Tell us, what is your secret to trying to get all this done, yet also being very calm and having nirvana at the same time?
Thank you, Jack. Maybe it helps to be from India, but to be really successful, have scientific breakthroughs and have an impact on society, you have to be an artist, you have to be an engineer, and you have to be a scientist.
Tell us more about that.
And I think it's very important to appreciate what you're doing, because as much as of an scientist, I really enjoy the process of how do you engineer all the systems, how does it make an impact on human society, and so on. And so you really have to be an artist. You have to think like a creative person. Otherwise, it can become very jarring, very boring very quickly. And so the joy of creating something new, being an artist about that is very critical. And being an engineer and scientist, you have to kind of constantly change your roles back and forth. I mean, my training is as an engineer, but as a professor, as somebody who runs a large group, we're always looking for those scientific breakthroughs. And I think it's been a fantastic journey. And I have spent a lot of time with you, and we are kind of journeymen
both
together.
Inside Google and outside as well.
Exactly, in many ways. And we're just fortunate that we live in an era where we can really tap into our inner potential to make an impact on society.
Let's talk about inner potential, because you and I both mentor others. You have many students that you've mentored over the years. I don't know how many master's and PhD students you've had, but so many people have been impacted by yourself. How do you balance the ability to mentor and nurture a new talent that is one of your students, but also drive them to great achievement? How do you get that balance right?
Yeah, I coach, young talent from all the way from high school to my students, to startups, to large organizations where I work. And I think you have to kind of always take a balanced approach, being very prescriptive and kind of be inspiring. And I think there's kind of a negative connotation to be very prescriptive about when you're coaching somebody. And I don't think that's right. I think it's perfectly fine to say, at this stage, I think this is the right thing to do. Do you believe in my leadership? Do you believe in my mentorship? At the same time,
because you've had pattern recognition from previous. Yeah.
Pattern recognition, also understand the knowledge graph around it. And fortunately, many of my students, many of the founders who I have worked with, come back 5-10 years later saying, Ramesh, I'm really glad you sat me down and you said, this is the most important thing to do right now.
They appreciate it then.
They appreciate that, not in that moment, but much later. But I guess you have to be careful about doing that. But I think the tools today will allow us to kind of clone ourselves, a clone of Jack, a clone of Ramesh, and hopefully we can have an impact on the next generation in a scalable way.
Wonderful. Let's now talk to AI. Let's talk about AI. Our passion, you and I, are science, AI for science.
Right.
Of course, there's language AI, many wonderful applications. People and companies should be cutting costs for customer service with AI, with language AI.
Right.
Wonderful. But let's really turn to the passion you and I have for discovery and impact with AI for science. What are your thoughts? How do we approach that, going beyond just language models to the kind of quantitative side?
Yeah. I mean, if you just think about kind of the tip of the iceberg, the classic analogy, above the water is things like ChatGPT and language models that are mainly accessing public data or text data that has been fed. And with autoregression, we have seen some magical abilities for these platforms. But I think below the water, what's submerged is this world of not just data, but also simulations. Because the breakthroughs we have seen in physics and chemistry and so on have clearly come because of some representation of the physical world. And I think Max Tegmark at MIT has some beautiful papers that shows that the reason why we can actually train machine learning models is because the underlying formulas of nature actually are pretty simple. But unfortunately, the trends in language models to get away from that abstraction and just use data, raw data as an input. And I hope we really move away from that and try move away from the notion of AI as an assistant, of library of information, to AI as an engineer, where the AI has access to a simulation, to AI as a scientist, where there's a very large gap between the simulation and reality. So I think autonomous vehicle is an example where AI can be an engineer because the gap between simulation and reality is not that large. But when it comes to discovery of drugs, the gap is very large. So you really have to think of AI as a scientist, where the rewards in a reinforcement learning paradigm are very sparse and very, very inaccurate. So how do you treat AI as a scientist when the gaps are large and the rewards are very sparse?
And what's exciting is I think using these kinds of techniques, we can think about real big leaps in the next 5 to 7 years.
Yes.
In biology, in medicine, in chemistry. We need that to happen.
Absolutely, absolutely.
Yeah.
I think as biologists, as chemists, as fundamental scientists, the effort has always been on creating the right kind of simulations. But I think that has to be upgraded for the machine learning world, for the AI world, because you need some kind of a functional approximator that has a universal way to express the inputs and outputs. And if you think about deep learning revolution, it's basically simply mapping a vector to another vector or a matrix to another matrix. And unfortunately, in the simulation world, we haven't figured out a common language for input and output. So the way a physicist versus a chemist versus a biologist will talk about the underlying phenomena is not in the common language. So a lot of the research we do here at MIT is really focused on how do we create this common language between different sciences.
Just to finish with a concept, in my time in India, one of the Hindi words I came away with is Jugaad.
Jugaad.
The ability to, like MacGyver-like, take what you have and make it work,
Right.
make it happen. What does that word mean to you? What does that philosophy mean to you of making it happen?
Yeah, I think it has different connotations. And Jugaad is like the, behaving like a MacGyver. It allows us to make a rapid progress with brute force.
Yeah.
Whatever it takes, keep making progress. Don't be scared with the complexity of the problem. And I think AI, in a way, has done Jugaad so far. But unfortunately, as you and I know, we need to move away from the Jugaad mindset to have a very scientific mindset to it. And I think if you look at the human society, the way we work is, we are born with some hardware but very pathetic software. And at 3 months or 6 months, over time, we get taught by our parents. We go to reasonably good schools. We go to good companies. We go to good cities, and our software continues to improve. And so the same is going to happen in AI as an engineer, AI as a scientist, and also the way population behaves in India, which is individually you may not be as smart, but collectively, how do you become smarter? So we have to create quantitative models, but also population models.
Yeah.
Where different, and people use agents or whatever term you want to use, but these different micro AIs that can work with each other and get better together. And that can be at an individual level, but also be at a molecular level. Imagine attaching a program to every molecule and being able to figure out how they interact with each other so that collectively they go on to discover something interesting. So I think the Jugaad philosophy from India is a good start, but I hope we move beyond that
too.
and have a scientific abstraction that allows us to deal with millions, maybe hundreds of millions of micro AIs.
Ramesh, you're an inspiration. You're a mentor to so many. You've had massive impact. I look forward to more collaboration together. Ramesh.
Thank you, Jack.
Wonderful. Great to be with you.
Good to see you.